In this lecture, we are going to learn the guidelines for achieving a high-performance concrete pavement or flooring work. Tremix is also called vacuum dewater flooring, or simply VDF. Through a vacuum dewatering process, surplus water from the concrete is removed immediately after placing and vibration of concrete. The process of suction of water reduces the water-cement ratio to the optimum level. Through the reduction of water-cement ratio, especially at top, the compressive strength and density of concrete increases. This provides better wearing and tearing properties of the concrete surface. Generally, the mix of concrete is M20 or M25. The PCC base, below the RCC surface, should be kept up to 100 mm thick. The RCC thickness varies between 100 to 200 mm, depending upon loading required. Tremix system is commonly used in making industrial floors, concrete roads, runways, railways platforms, warehouse container yards, canal lining, pathways, bridges, RCC roads, etc. Following demands should be considered while constructing a floor. Wear resistance. Prevent aberration due to vehicle movement. Joint strengths. To prevent chipping of concrete at weak joints. Impact resistance. Prevent damages from impact of falling objects. Slope requirements. For proper drainage of spills. Concentrated loads. As in case of machinery loading. Surface flatness. For installation of racks. Along with regular concrete mason tools, special tools required for Tremix flooring work are vacuum dewatering pump, floater machine, Tremix mitt, and double beam screed vibrator. The Tremix process involves following 8 steps: fixing of guide rails, placing concrete, concrete spreading, surface vibration, leveling, vacuum dewatering surface, suction of water, power floating, power troweling of the top surface, and last curing to gain strength. The benefits of Tremix flooring. Due to removal of excess water, the compressive strength of floor increases by up to 60%, resulting in higher structural strength and durability. There is also an increase in tensile strength, and abrasion resistance of the floor increases by up to 70%. Additionally, cement consumption is reduced, as no additional cement is required separately for finishing the top surface. As concrete surface becomes denser, permeability is reduced, as a result of which, liquids falling on the floor have less detrimental effect on the concrete. Impact strength is increased. Shrinkage of concrete is reduced and the floor warps less. IPS versus Tremix. IPS, Indian patent stone, usually uses over terraces. Mix is usually less than 10 mm aggregates. Provides economical surfaces with proper sloping finish. Usually up to 125 mm thick. Tremix uses for floor grades 20 mm Ca with regular concrete. Provides better strength, durability. Usually 150 mm to 300 mm. Challenges during Tremix. Settlement of concrete might occur due to removal of water. During hot temperature, concrete sets quickly, causing shrinkage cracks. There is also possibility of removal of fine particles such as cement. Additionally, there is possibility of removal of water, which might be required for hydration. Placing sequence. In most cases, the efficient way to place concrete in large areas is in long alternating strips, called panels. Reinforcement needs to be tied for each panel. A checkerboard sequence of placement is commonly used, which permitted concrete shrinkage of casted panels before adjoining pavements are casted. Roughly 80 to 120 square meter of area can be covered in a day by a concrete mason by using a walk-behind floater and a trowel. Assuming a width of panel to be 4 meters, a 30-meter long panels is usually casted. However, experience has shown that shrinkage of the earlier placements occurs too slowly for the checkered board method to be effective. Newer recommendations are that the checkerboard sequence of placement not be used any longer. Instead, large block of concrete placements, up to 2 bays wide, should be followed. This can be achieved by using ride-on trowels, a trowel in which an operator sits on a seat installed upon the machinery. Sheet of plastic are used as vapor barriers. It helps protection from the transmission of moisture upward through the concrete slab, from sources in the base and sub-base layers. The thickness of plastic sheet depends upon the amount of protection required, and the moisture sensitivity of the local ground conditions. It can be placed directly beneath RCC surface or on layer of granular fill, below PCC. Precaution against evaporation. Rapid evaporation and moisture loss can result in plastic shrinkage, cracking in the slab surface. This undesirable appearance can be prevented by using windbreaks or sunshades, or treating the concrete with a thin water film just after using power trowels. Surface tolerances. In the past, floor profile quality had been specified by limiting the size of the gap measured under a 3-meter-long aluminum piece placed anywhere on the floor. Recently, the floor quality is measured in 2 different numbers. The flatness number controls the floor surface by limiting the magnitude of successive 1 feet slope changes measured on a predetermined line. Flatness is usually controlled by construction methods and finishing techniques. The levelness number defines the relative conformity of the floor surface to a horizontal plane as measured over a 10 feet distance. Levelness is controlled by precise forming, or by the use of a laser screed. Range of surface tolerances. The range of floor tolerances being achieved per historical data is: for a bull float, average flatness received will have a variance of 13 mm. By using a double screed surface vibrator, the flatness achieved is 8 mm variance. The best quality is achieved by using a laser screed. Surface flatness of up to 3.2 mm can be achieved.